Assalamu alaikum. Today we will see lecture number 26 from the subject numerical methods. Today we will do two more examples from the topic Newton's forward difference interpolation formula. The first question is, as you are seeing that we have given all the data points and these are the function values, and this is what we have to estimate. We have to estimate the value of y when x is equal to 2.05. So you know that our data points are equally spaced. The difference is 0.1. That means in this question the interval size is 0.1. So yes, we can solve this question. Before solving this, we have to construct the difference table first, right? Because that is most important. So we have how many points? 4. So xi, yi, 2.0, 2.1, 2.2, 2.3, 11.0. This is the data which is already given to us, but in order to construct the Newton's forward difference table, we will write it in the tabular form. So the first order will be this minus this. So the result, I have already calculated this. So but please, when you do any question at home, always calculate yourself. Sometimes it's not, sometimes mistakes might happen and the calculations can go wrong. So this is this minus this, then this is this minus this. Okay, then this is delta cube yi, because we can make one more differentiation and that's it. You know that this point is delta y1, this is delta y2, this is delta y3, this is delta square y1, delta square y2, and this is delta cube y1, right? Okay, now we have to estimate the value 2.05. 2.05 comes between these 2 points, right? 2.0 and 2.01 के दरमियान में हमें इस point को estimate करना है. And as I told you earlier, when we have to solve the or estimate the values using Newton's forward difference interpolation, we have to estimate it at the upper half of the table. So we will estimate this at this point. We will estimate the value at this point. So that means we have to generate the formula up to the third order. So the formula will be like this: y of x will be equal to y1 plus delta y1 times u plus delta square y1 divided by 2 u into u minus 1 plus delta cube y1 divided by 3 factorial, that is basically 6, u into u minus 1 and u minus 2. Now in order to substitute all the values, we know each and every value. We know the value of y1, we know the value of delta y1, we know the value of delta square y1, we know the value of delta cube y1. What we don't know is our u. And as you know that our h is equal to 0.1 and our u is always equal to x minus x1 divided by h, which is equal to x is given to us, that is 0.25, x1 is given, that is 0.2, and h is 0.1. After calculating this, the value will be equal to 0.5. This will be our u. Now substitute all the values in the formula. So y of 2.05 will be equal to 11.0 plus 1.261 times 0.5 plus 0.126 divided by 2 into 0.5, 0.5 minus 1 plus 0.006 divided by 6 into 0.5, 0.5 minus 1 and 0.5 minus 2. So when you will simplify this, the result which you will get is equal to 11.60. So the value of y when x is equal to 2.05 is 11.60. Question number 2. Let me take the question from the book so that we can solve this. Okay, see, the question is like this: find the cubic polynomial which takes the following values: x 0, 1, 2, 3, f of x 1, 2, 1 and 10. एंड एक तो हमें क्यूबिक पॉलिनोमियल फाइंड करना है एंड ऑल्सो फाइंड f of 4. That means when the value of x will be 4, what would be the value of the function? You can write y of 4 as well, of f of 4, one of the same thing, and the derivative of f of 4 using Newton's forward interpolation method or forward difference interpolation method. ठीक है? So this is a question. So firstly we have to construct the forward difference table. So let us do that. xi, yi, delta square yi, delta cube yi, because we have 4 points. So this is how long we can go: 0, 1, 2, 3, 1, 2, 1 and 10. Delta y1, 2 minus 1 is 1, 1 minus 2 is minus 1, 10 minus 1 is 9. Minus 1 minus 1 is minus 2. 9 minus minus 1 is 10. 10 minus minus 2 is 12. So this is the Newton's forward difference table. So in this case our data points are equally spaced, so our interval size is equal to 1. So clearly we can calculate our u, x minus x1 divided by h, because x is given. That is, what is our x? Our x is not given. We don't know what is our x. X minus x1 is given, that is 0, divided by h is 1. So our u is equal to x in this case. Okay. Now we have to generate it up to the third formula, because we constructed the table up to the third order. So y of x will be equal to y1 plus delta y1 times u plus delta square y1 divided by 2 u into u minus 1 plus delta cube y1 divided by 6 u minus 1 u minus 2, because this was 3 factorial, so that is 6. What is our y1? 1 plus. What is delta y1? 1. What is our u? X plus. What is delta square y1? That is minus 2 divided by 2. What is our u? That is x minus 1 plus. What is delta cube minus 1? That is 12 divided by 6. This is x minus 1, x minus 2, which is equal to 1 plus x. ये 2 और ये 2 कैंसिल हो जाएगा. This is a minus, so minus x into x minus 1. ठीक है, plus 6 1s are 6, 6 2s are 12. So this will be a 2x, x minus 1 and x minus 2. Okay. So finally this will be 1 plus x minus x square plus x plus 2x square minus 2x x minus 2. Simple simplification करना है. 1 x minus x square plus 2x plus 2x square minus 2x square minus 2 to 4 x 2, this is 4x square plus 4x. Okay. 1 second, let me cross check this whether this is correct or not. 1 minus x square plus 2x, this is plus 2x cube. It's minus 2x square minus 4x square plus 4x, okay, is equal to, so y of x will be equal to 2x cube minus 4, 5, 6 and 7x square plus 4, 5, 6, 6x plus 1 in the polynomial form. So this is the polynomial. Our question was to find the cubic polynomial, so this is the cubic polynomial which we derived. Now the question is that we have to find the f dash of x, that means the derivative of this function. You know what that will be equal to. 3 2s are is 6x 2 minus 14x plus 6. Okay, now the second part of the question is, after finding the derivative of the polynomial, we have to substitute the value 4 in the equation, in the derivative of the equation, so that we can get the values as well. What that would be, substitute firstly 4 in this equation. So our y of 4 will be 2 into 4 ka cube minus 7 into 4 ka square plus 6 into 4 plus 1, which will be equal to 41. And our f dash of 4 likho or y dash of 4 likho, doesn't matter. 6 into 4 ka square minus 14 into 4 plus 6 will be equal to 46. So this is it. This is how you can solve this. Thank you so much. Have a nice day ahead. Tomorrow we will do Newton's backward difference interpolation polynomial and the questions. Thank you.